So in question number 6, we're basically just going to put all the pieces together for what we've discussed in questions 4 and 5 by making a common base and walking through the steps to just make sure we understand from beginning to end how to start with an exponential problem that has 2 different bases and how to create a problem that has only one consistent base so that we can make a really easy equation to solve. If you feel like you already understand the main idea, you probably don't need to watch this video, but just as a heads up, I'm going to do the first column's worth of problems on the page. So I'll do letter A, letter D, and letter G in case you feel like you need some examples. And of course, if you want to do one or multiple takes through this video, or if you want to fast forward to the parts that you want, like if you're fine on A and D but letter G looks difficult, feel free of course to do that too. So in letter A, the first step is going to be identifying what the potential common base will be. I usually like to look at the smaller one first and to ask myself, can I make the bigger one look like that? If the smaller base is already a 3, then I'd say, can I make a 9 look like a 3 with a common base or an exponential expression? And I can, because 9 is 3 squared. So I know for sure that my game plan is going to be keep the left side, change the 9, and then have our common base ready to go. So I'm going to keep the left side as 3 to the power of 5x minus 4 equals, I'll put parentheses where the 9 used to be just to show that I'm changing that, and then I'll keep the power of 2x minus 1, because remember the 2x minus 1 is fine. It doesn't need to change. It's just the 9 that does. Inside those parentheses, I'll write 3 squared, because that's my common base, and that of course keeps me equivalent to 9, so I haven't really changed the equation at all. And now I'll have really my focus drawn to the exponents. I like to highlight my exponents. It's just a habit that I like to do, but you of course don't need to. That's just where you need to focus your attention, literally or not. So 5x minus 4 remains unchanged, equals, and then we have 2, which is the new exponent on the inside, times 2x minus 1, the old exponent that was already there, which gives me 4x minus 2. Remember, you're basically distributing the new exponent to the old exponents. If you start to solve, we can subtract 4x on both sides. That will cancel the 4x's. Then we can add the 4 to the left. So it looks like then we end up with, if we clean it all up, 5x minus 4x is x. And then negative 2 plus 4 is 2. And that looks like our final answer. It's always a good idea to either check the key or plug in, especially if you have a calculator handy, to make sure that the 2 really is a legitimate solution. So if I go to my calculator and type, I have 3 to the power of, and then I have 5 times, we just said the new solution is 2. So 5 times 2, or you can use more parentheses, minus 4. Remember, I don't care what the answer is. I just want to make sure that when I plug into the right-hand side of the problem, it matches. So if I do the right-hand side, which is 9 to the power of 2 times 2 minus 4. Oh, sorry, minus 1. My bad. Ignore. There we go, 729. So ignore that. Now we know for sure that the top and the bottom calculation gives us the exact same answer, which means our solution works on both the left and the right-hand side of the equation. We can do letter D as another example just so you can see it, but hopefully now you've kind of got the flow. First thing I'll do is I'll look at the exponents that are there and I'll ask myself, can I make the bigger one look like the smaller one? 8 is a power of 2. It's 2 cubed. So my game plan is going to be change the right-hand side of the equation so that it has a base of 2, but leave the left-hand side untouched. So I'll have 2 to the power of 2x, not changing that at all. I'll put parentheses around the 8 because I am changing that. And then x minus 4, of course, needs to stay there because I'm not changing that. 8 is, as we said, 2 cubed. So now I have the problem that I'm trying to solve. Specifically, I have the exponents that I'm trying to solve because that's where all the action is. I have 2x on the left, which again remains unchanged, equals 3 is going to have to multiply the x minus 4 that was already in the exponent spot. So 3 times x is 3x. 3 times minus 4 is minus 12. And now I have an equation I can solve. It's not the prettiest equation, but you could subtract, let's see, you could subtract 3x. So you'll have negative x equals negative 12. And if you have that, then you can divide by negative 1. and end up with x equals positive 12. Again, it might be a good show of form just to quickly check that, make sure everything looks good. If I plug into my equation, sorry for the glare there, if I plug in the 12, 2 to the power of 2 times 12, a gigantic number that I don't really care about because I just want to check that it's okay. So then I'll check 8 to the power of 12 minus 4. And we got the same ridiculous number. So it doesn't matter what that number is, we just know it matches, which means 12 works on both sides of the equation and it's good to go. The last one, letter G, is where things get interesting. Because if I start to game plan and I'm circling the bases I need to consider, I'm looking at 8 and I'm looking at 16 and going, uh-oh, now we have a problem. Because 16 is not a power of 8. 16 is divisible by 8, but it's not a power of 8. Because remember, power of means like 8 to the power of 1, 8 to the power of 2, 8 to the power of 3. But none of those are going to give me 16. 8 to the power of 1 is too small, but 8 to the power of 2 is too big. So I can't just change one side of the equation in this case. I have to come up with a common base that's going to work for both, because it's not possible to make the 16 have a base of 8. I'm going to have to change them both. So now let's maybe think, like, what could we use as a common base that both share some similarities? My instinct is usually go small and just keep it simple. So for example, 8 and 16 are both powers of 2. Let's just do each of these as a power of 2. 8 is 2 to the power of 3. 16 is 2 to the power of 4. So we'll just change both parts. And that's okay. Sometimes you have to do that. I have 2 to the power of 3, which is going to go into the parentheses, but x plus 3 is going to stay unchanged, so I'll write my parentheses first. And then on the right-hand side, I'll put parentheses where the 16 used to be, but I'll keep the x there that used to be there, because again, it didn't change. In the left-hand side parentheses, what used to be an 8 is now 2 cubed. In the right-hand side parentheses, what used to be a 16 is now 2 to the power of 4, and now I have the exponents that I need to solve. This time, I really do need to be careful with my multiplication because I've changed both exponents. 3 times x plus 3 needs to be multiplied. So that would be 3x plus 9 equals 4 times x. I can just multiply it as 4x. This equation does look a little easier to solve. I could subtract the 3x to the right-hand side, for example, and I'll get 9 equals x by itself, so that we know the solution must be 9. And again, one last time, you can quickly verify and just make sure that's okay. Usually to verify, you just quickly plug in and make sure everything looks like it's good to go. So 8 to the power of 9 plus 3, giant exponential. This is standard scientific notation, which means the answer is so big we can't even fathom it on our calculators. But on the other side, 16 to the power of 9 gives us the exact same crazy exponential. So we know that it's definite, or scientific notation. So we know it's working, and we know that 9 must be a legit answer. I will give you a hint that there are several problems, like letter G, where you're going to have to change both bases. So just as kind of a heads up, it's mostly just an FYI, but it's worth noting. Letter F is one of those problems where you'd have to change both bases in order to get a common match. Letter H is another one, and letter I is another one. So just be prepared for that on letters F, G, H, and I, you have to change both exponential bases to get a match to work. The answer key is posted. Make sure you check it. And of course, if you have any questions, don't hesitate to send me an email or join in on the Zoom, and I'll be glad to help.